Here's a summary of some of the sequence behavior of different functions. Okay, if the first difference of a function is a non-zero constant, then we expect a linear fit. If the second difference is a non-zero constant, we have to use a quadratic, and we should get a good fit with that. Third difference, non-zero constant, we get a cubic fit. If the nth difference is a non-zero constant, we get a degree n polynomial. We now look at the process of linearizing a function. The situation here, we're given the function y equals 5x squared. We're asked to make a table for this function using x equals 0, 3, 6, and 9, which we do, just substituting these numbers in for x, we get these. And then we're asked to linearize this function. Okay, we can linearize this using the function square root of y. Taking the square root of y, transforming y by taking its square root. When we do this, square root of 45, 6.8, 180 gives us 13.4, and so forth. And I think these are probably right to within a tenth. Could have a little bit of discrepancy, I don't know. But we see that the differences of these numbers are indeed constant. Difference here is 6.8, 6.6, 6.7. To the nearest tenth, these are all the same number, so it seems that we have indeed linearized these functions. Now it's important to understand that the differences being constant only gives us this kind of information if we have the same difference between our x numbers. If the difference between the x numbers is not the same, then we would have to actually calculate the delta y over delta x. Since the delta x's are all the same, if the delta y's are all the same, then the delta y over delta x is all the same. And we just make a note. Same to one decimal place with the same precision as the data implies that the function is linear. We will note that since this is a power function, y equals 5x squared, a log y versus log x transformation would have also worked. Okay, that works anytime we have a power function. In that case, our delta y over delta x would have been constant. But we would have had to calculate delta y over delta x because after we take the logs, our delta x would no longer be constant.